Assalamualaikum warahmatullahi wabarakatuh. My name is Jihan Nabila Fitrasani with student ID 22060 Here I will explain my answers for my finals in numerical methods. So there are two main questions, which is about a standard version of military application of spring mass system, and then the last one is about to describe my comment about Elon Musk question to AGI or her. So I will answer the first question, which is the version of military application of Supreme System. So the first thing is to do muhasabah, which is to measure yourself realistically. So if I was asked to evaluate myself, I'd say I have a lot of flaws, especially in class. It took me a lot of time to process things being taught. It's one thing that has been bugging my mind. It was said that consciousness comes naturally, and I agree. A lot of time I would just realize I had been drowning in focus without me realizing. But in some days, that consciousness towards the things we were learning didn't come as easily. And it happened a couple of times in the middle of a class, but knowing that I'll try my best to keep my focus around what's being taught. I also had some days where my mood affect my performance in class. May it be because of personal problem or it was just the usual bad day. But same with previous problem, I will try my best not to let my personal affair affect my attendance in class. My biggest pride in this class is the amount of effort I've put to get the best results, whether it's the knowledge that I got or even the marks I'll get for this class. I've never missed any class. I've made a total of 14 videos on my YouTube channel, and I've always done uploading the videos or finishing tasks right on time, never late in posting them past 23:59. I always just answered when Padai asked things to me. With knowing that I'm not perfect nor will I ever be, but I always tried my best to give the best effort I could put in this class. Therefore, I think I deserve to get at least 85 points for this class. And then we will get into the main question, which is to use die 5. The first point, which is intention. As always, the main intention in solving a problem is to pay our required fulfillment to our Lord Allah Subhanahu wa Ta'ala. Because we already have the foremost intention, we can get the leading intentions as a way to solve our main problem. In this case, the leading intention is to analyze comprehensively things circling around military applications of spring mass system. So in initial thinking, since we were sent the PDF about this problem, we can build up our answers from the PDF. Therefore, in initial thinking, since in this point we have to elaborate all the values that we have in the problem. So the values mentioned are the nature of the problem and the properties making up the problems. Since only categorizing the problem into two categories can be a complicated task, hence we can simplify the task at hand by categorizing the values in the problem into 6 groups, or known as 5W plus 1H, which is who, what, where, when, why, and how. Based on the material given by Padai, we can write 5W plus 1H as first the who, which is the person being connected to the problem. So in the PDF, we have newly stationed officers that joined bestly with McCart, particularly those in the 51st Expeditionary Signal Battalion. And then we have ATC engineers at Aberdeen Proving Grounds, battalion commander, and colonel from the U.S. Army Test and Evaluation Command. That's what ATC is. And then the what, we get into the what. What is going on? What are we trying to search in this problem? So what we have in this problem. So what we have is it's about project. In the project one, it's about testing and analysis for ATC engineers regarding the suspension systems of satellite transportable terminals, or STTs, and their response to road terrain and operational stresses. And then we have the objective one, which is to model and recommend optimal suspension system that prevent damage to sensitive equipment. equal to satellites during transportation even over rough terrains and under operational conditions such as weapon firing. The question of where is the location, which is in Joint Base Lewis McCord, WA, and the Aberdeen Proving Grounds for ATEC. The when is when we are going to solve the problems, which in this PDF it is mentioned we just finished our training, and after completing the basic officer leadership course or POLC, and during the first study station assignment of the new officers. Then we get to the why. Why do we need the Supreme system, which is to ensure structural integrity and operational effectiveness of military vehicles and equipment. Proper suspension systems are crucial to avoid damage that could lead to high repair cost and mission failure. And then we get to the last part, which is how. In how do we solve the problem? So we have the modeling, which is using mathematical modeling and differential equations to simulate the behavior of suspension systems under various conditions. And then we get into the simulation and analysis, which is running simulations of the STT trailer-based system over right terrain using direct delta functions to represent impulses caused by rocks and other terrain features. And then we get to the last point, which is experimental data, which is to utilizing data from field tests, such as the firing of mounted machines, guns, to validate and refine models. This analysis helps in understanding the comprehensive approach required to address the Supreme system challenges in the military applications, ensuring the durability and reliability of equipment under operational conditions. From the 5W plus 1H we got, we can then start grouping them to the nature of the problem and properties of the problem. First, the nature of the problem is our suspension systems of satellite transportable terminals, or STTs, and then the military applications, we get battalion, and the BOLC, and ATEC. And then we got to the properties, which is the parameters going to be used to make the spring mass system. We have the xt, or x in time, which is displacement over time, and then the m, or mass of the object, and then the beta as damping constant, and then we have lowercase k for spring constant, and then we have ft, or force over time, which is external force, and then we have w, or omega, which is a concentrated load applied, and then we have delta t, which is direct delta function, n as number of impulses, and theta as time between impulses. And then we get to the last part, which is idealization. In this part, we make assumptions of the parameters we have, which is a uniform distribution of mass and forcing function. The mass of the vehicle and any forcing function on the suspension are assumed to be evenly distributed. This allows the suspension system to be treated as one shock rather than multiple interacting components. And then we assumes that simplified suspension systems. The suspension systems is modeled using a single degree of freedom, or one-dimensional motion, and described by the differential equation. And then we also assume that the condition is equilibrium. It is assumed that the loaded trailer is at equilibrium initially, meaning that the displacement of the shocks before loading the trailer is zero. And then we get to initial conditions. In initial conditions, for the modeling of the spring mass system, initial conditions are assumed to be x0, or we get that it was the displacement s0. So the displacement at 0 time is 0, and its derivative as also 0. This simplifies the solution of the differential equations. And then we get to the forcing function. The external force due to terrain and operational conditions is modeled as a specific function of time. Means force over time is 200 sin 4 t, 4 multiplied by 4 and times. These assumptions allow the use of analytical methods to solve the differential equations. And then we also make assumptions of the critical damping. The critical damping condition is considered to avoid oscillatory motions. The damping coefficient is compared to this critical value to assess the performance of different shock systems. And we also make assumptions over the impulse modeling. Rock terrain is modeled using direct delta function to represent impulses from rocks. This assumption allows the terrain effect to be incorporated into differential equations in a mathematically convenient manner. After we make assumptions, we can make the model of the system. Since it's a mass spring system, the modeling will be m delta dx per dt, but it's square, so it's d square x per dt square plus beta dx per dt plus kx equal to ft. Since all these parameters we have mentioned in the properties here, we can move to another model that we will use. After modeling, we can start to find the calculation needed to use the model equation, right? And here, to get the beta, since we don't have what beta is 2 root mk with bc or beta c as the critical damping coefficient. In another problem, we need to model the impact of impulses, which is maybe the terrain effect using direct delta functions. So the force over time is omega 0 sigma over n, starting with n equal to 1 delta t minus 2n minus 1 theta. And then we get to the last point, which is instruction. And this point is used to get a specific result by substituting the data given or the formulas used as modeling. Since the main problem is to find the applications of mass spring system in military, we use the formulas or apply it into the process of designing military weapons and vehicles. We can conclude that it can be called the application of spring mass system. The importance of spring mass system cannot be underestimated. By spring mass system can enhance mobility and durability. Reducing the impact forces on vehicles and equipment increases their lifespan and reliability. Spring mass system also increase soldier safety by mitigating the effects of shocks and vibration. Spring mass system protects soldiers from injuries, enhancing their effectiveness and survivability. Another important role the spring mass system holds in operating efficiency and energy efficiency. It is ensuring that the equipment remains functional in harsh conditions, improves the overall effectiveness of military operations, and it's also important to harvesting energy from movements reduces the need for external power sources, making operations more sustainable. With a big roles the spring mass system hold in military field, there are a lot of applications in military that uses the spring mass system, which is first the vehicle suspension system, shock absorption in armor and helmet, vibration isolation for sensitive equipment, energy harvesting system, training simulators, deployment and parachute system, stabilization of mounted weapons, antenna stabilizations, and landing gear for drones. And then we get to the last question, the main question, which is to describe my comment about Elon Musk's question to AGI or she. So, in my opinion, since artificial general intelligence or AGI is a field of theoretical AI research that attempts to create software with human-like intelligence and the ability to self-teach, right? In a simple way, AGI is basically an AI that's trying to be as humanly as possible. That's what my take. Though it might not be physically, but they're imitating human based on intelligence. They're hoped to be able to make their own decisions and way of thinking. As Elon Musk asked AGI what's outside the simulation, It's interesting to me because AGI is only part of a simulation program without actually having a shape. And because AGI is expected to act like a human being, it will be exciting and entertaining to see what's basically a robot thing of outside their world. It's like asking a human what is outside the universe. Is there anything outside the universe, or is that, or is the whole universe is just what it is? So I really like how the Elon Musk asked the question because I want to see what AGI will react and what AGI will answer to that question. And that's all for my explanation about my finals in numerical method. Wassalamualaikum warahmatullahi wabarakatuh.